Section A, 14 marks. Question number 1 A. In questions 1 to 7 given below, choose the correct alternative A, B, C or D. Question number 1. A fish called an electric eel can generate a voltage up to 800 volts if it can supply a current of 5 milliampere. The maximum power it can deliver is. Options are A 4000 watt, B 400 watt, C 40 watt, D 4 watt. Required formula is power equal to voltage into current. In this case, voltage is 800 volts and current is 5 milliampere, which is 5 into 10 to the power minus 3. Therefore, 800 into 5, 4000 into 10 to the power minus 3. Answer will be 4 watt, which is option D. So, option D is correct answer, 4 watts. Next question. Second question. A collimated beam of protons is traveling with a constant velocity along x-axis. There is a current carrying solenoid whose axis is also x-axis. If this beam now enters the solenoid along its axis, it will describe a circular path. Option A. Option B, get deflected along z-axis. Option C, get deflected along y-axis. And option D, continue to travel undeflected. In this case, for a deflection, the motion of protons must be perpendicular with the direction of magnetic field. In that case only we get deflection. But in our case, it is clearly mentioned that the protons are moving along x-axis, which is also the axis of the solenoid. And we know for the solenoid, the magnetic field direction is also along the axis. So therefore, if we draw the solenoid, then the magnetic field lines will be in the direction, if it is north-south, then in the direction of the axis. Therefore, the motion of the protons are also in the same direction as it is parallel. So, motion of the protons and magnetic field both are parallel. So, as a result, we get no deflection in this case. So, as a result, we will go with option D, where the particles, the protons continue to travel undeflected. Option D is the right answer. Next question. Question number 3. An electron, a proton, a deuteron and an alpha particle are all accelerated from rest through the same potential difference. Which one will have the maximum de Broglie wavelength? So we need to find out the maximum de Broglie wavelength. Options are option A proton, option B deuteron, option C electron, option D alpha particle. In this case, we know lambda equals to h by p, where p is the momentum of the particle and lambda is the wavelength. So again, kinetic energy of the particle is equal to electronic charge times potential. So in this case, we have 4 individual particles, and if we draw the formula together, it will give us lambda equal to h by mv. This v is the velocity as p is the momentum. Again we know p square equal to 2 into mass into kinetic energy, that is Ke. So therefore we can write 2m, instead of K we write E into V. This is electronic charge. So in this case, if we put the value here, we will get lambda equal to H by root over 2MEV. So as a result, lambda is equal to H by 2M. We can write Q instead of E. So therefore root over 2MEV. Now in this case, H is a constant, so we don't want to keep this one. Then V is also constant in this case, as it is said, same potential difference. 2 is also constant. So we are left with the relation where lambda varies as 1 by root over mass times charge. Now if the particle, which one is massive as well as having higher amount of charge, will get the lambda as minimum. So in this case, we need to find out the particle which is having lower mass and charge. So amongst these four, if we check, normally protonic mass of a proton is almost 2000 times the mass of an electron. And for deuteron also, mass of deuteron is 4000 times the mass of electron. Now in the case of an alpha particle, the mass is almost 4 times, that is 8000. And in the case of electron, we all know normally it is Me, which is 9.1 into 10 to the power minus 31 kilograms. So in this case, electronic mass is the lowest one. And in the case of charge as well, if we look at electronic charge, which is just E, and which is also the charge of proton, but in the case of deuteron, the amount is also almost the same. But in the case of alpha particle, we get 2 times charge, that is Q alpha equal to 2 into E. Therefore, in all the cases, from all this understanding, we get to know that electron is having the least mass and least charge among themselves. So therefore, the ratio in this case will be minimum for electron. So as a result, the lambda will be higher. So therefore, lambda maximum will be for electron. Therefore, the right answer in this case is option C, electron. Next question. Question number 4. Magnetic susceptibility of a material is found to decrease with the rise in its temperature. The material is option A, diamagnetic, option B, paramagnetic, option C, ferromagnetic, and option D, not magnetic. So in this case, for diamagnetic substances, we know that the chi is not related with temperature. That means chi is not a function of temperature. In the case of paramagnetic substance, the chi is related with T in the inverse manner. So the time it is related to chi is inversely proportional to temperature. For ferromagnetic substance, the relation is C by T minus Curie temperature. So in this case, it is not that directly related with the decrease inverse relation. So in this case, as the most preferable answer will be option B as paramagnetic substance, as it is having a inverse relationship directly visible. In ferromagnet, it can also be the answer, but there is a limitation of Curie's temperature. After that, it behaves like a paramagnetic substance where the inverse relationship is followed. So in this case, the most suitable answer will be paramagnetic. So option B is the correct answer. Next question. Question number 5. When a PN junction diode is forward biased, the options are: it acts as an insulator and no current flows through it. It is a wrong option. As for forward bias, we know that PN junction behaves as a on switch. That means in forward bias, PN junction almost carries all the current. So in this case, option A, it does not behave like an insulator. So the option A is not a correct answer. Option B, it offers a low resistance and a large current flows through it. So it is a correct statement. So we go with this one. Option C, it offers a high resistance and a small current flows through it. It is also incorrect. Option D, the width of depletion region increases. We know depletion region increases in the reverse bias section. So in this case, it is also incorrect. So we go with option B, as it follows. It offers a low resistance and a large current flows through it. So option B is the correct answer. Next question. Question number 6. When a biconvex lens of glass of refractive index 1.6 was dipped in a certain transparent liquid, it is found to behave like a plain sheet of glass. So the refractive index of the liquid is, when it behaves like a plain sheet of glass, that means the focal length become infinity. And we know the lens maker's law, 1 by focal length equal to refractive index of glass with respect to that particular unknown liquid minus 1 times 1 by R1 minus 1 by R2. Now in this case, if the focal length become infinity, so left hand side it will become 0, equal to mu glass by mu liquid minus 1 times 1 by R1 plus minus 1 by R2. If we take to the left hand side, so it will also turn as 0. So therefore we can clearly see that mu g by mu L equal to 1. Therefore mu g is equal to mu L. In this case, mu g is already mentioned here, which is 1.6. So therefore the mu L will also be 1.6, which is option D. So option D is our correct answer. Next question. Question number 7. Given below are two statements marked as assertion and reasoning. Read the two statements and choose the correct option. Assertion: in Young's double slit experiment, the first bright band for blue light is closer to the center than the first bright band for green light. As we know, the relation is y equal to m times d lambda by d. This is the expression for the particular band distant from the central maximum. So in this case, as we can see, both are first bright band, so we ignore the value of m, and rest of the things are also constant. So in this case, y is directly proportional to lambda, and for blue light we know that lambda b is less than lambda g. So therefore the statement, the first bright band for blue light is closer to the center than the first bright band, which is correct statement. So this assertion is considered as correct. Assertion is correct. Now for the reason part, blue light has a longer wavelength than green light. So from this relation we can clearly understand that blue light is having a lesser wavelength than the green light. So in this case, blue light has the longer wavelength is the incorrect reason. So therefore if assertion is correct and reason is false, therefore we go with option C, assertion is true and the reason is false. So option C is the correct answer. Next question. B. Answer the following questions briefly. Question number 1. Calculate the momentum of a photon having an energy of 4.8 into 10 to the power minus 19 joule. Required formula will be energy equal to momentum times speed of light. So therefore we need the momentum P equal to E by C, where E is already provided 4.8 into 10 to the power minus 19 and the value of C is 3 into 10 to the power 8. Therefore we get P equal to 4.8 and 3, it become 1.6. Therefore 1.6 into 10 to the power minus 19 plus 8, it will become minus 27. So 1.6 into 10 to the power minus 27, the unit of momentum will be kg meter per second. So 1.6 into 10 to the power minus 27 is the answer. Next question. Question number 2. What is motional EMF? Motional EMF. So motional EMF is induced due to the motion of a conductor in a uniform magnetic field. So in this case, if we have a uniform magnetic field into the plane of the paper and a conductor moving along the x-axis, then the conductor develops a EMF due to the motion across its end. So that is known as motional EMF. So therefore we can write motional EMF is induced due to the motion of a conductor in an uniform magnetic field. Next question. Question number 3. Calculate work done in moving a point charge Q through a distance d along perpendicular bisector of an electric dipole, which consists of 2 point charges minus q and plus q separated by a distance L. So in this case, if we draw a line and the two charges are placed minus q and plus q, and we also draw a perpendicular bisector at the midpoint, let us consider it as O, and the point charge q is moved through a distance d. That means this distance is considered as d, and this distance, the dipole, length of the dipole, is considered as capital L. Now in the question it is asked that work done in moving a point charge q. So therefore W equal to, the formula will be q times V2 minus V1. So in this case, as it is the point on the bisector and both are equidistant from these 2 points, therefore at this point the potential difference, the potential for plus q and potential for minus q, both are same and they cancel out, same and opposite. Therefore V2 minus V1 literally becomes 0, and as a result the work done become q times 0 equal to 0. So the answer is 0. Next question. Question number 4. Draw the symbol of a Zener diode. So we need to draw the symbol of a Zener diode. So as we know, the symbol of a Zener diode is, we need to draw a triangle and we need to mark like this. These are the terminals, positive and negative. Done. This is the answer. This is the symbol for Zener diode. Next question. Question number 5. A thin convex lens of power 5D is kept in contact with a thin concave lens of power 8D. So first one, P1, is a convex lens. For that the power will be plus 5D. And next one is the concave one, P2, is equals to minus 8D. We need to calculate the focal length of the combination. So therefore first we need to calculate the power, combination of the power, P equal to P1 plus P2. Therefore P1 is 5 and P2 is minus 8. So when we add them, we get minus 3D. Therefore, focal length F equal to 1 by P equal to 100 by 3, and we need a minus. So therefore, it will be 33.33 centimeters with a negative sign. So the focal length will be minus 33.33 centimeter. This is the answer. Next. Question number 6. The image below shows a compound microscope. Which one of the two lenses, L1 and L2, has the larger focal length? So for compound microscope, we know that the objective lens is smaller than the eyepiece for microscope. and for telescope the objective lens is bigger than the eyepiece. This is for telescope. So as we are talking for microscope, in this case our L1, which is the eyepiece, this is eyepiece, and this is objective. Same case here also, this is objective and this one is eyepiece. So in this case particularly we have microscope, therefore this is L2 is the objective and L1 is the eyepiece. So therefore we can write L1 is the eyepiece and L2 is the objective. So in this case L1 must be larger and L2 will be smaller. Larger focal length than L2. Next question. Question number 7. Radius of the first Bohr orbit of hydrogen atom is 0.05 nanometer, which we consider as R1 equal to 0.05 nanometer. Now we need to calculate the radius of the third orbit. So as we know, n is the principal quantum number, and r radius is directly proportional to n square. So in this case R2 by R1 is equal to N2 by N1 whole squared. Therefore N2 equal to 3 and N1 equal to 1 whole squared equal to 9. Therefore R2 equal to 9 times R1, which is equal to 9 into 0.05, that is equal to 0.45 nanometer, or we can write 4.5 into 10 to the power minus 10 meter. That's all. Thank you. The next section will be coming soon. Thank you. Stay tuned.